This is page 2 of section 7.5 class notes, and I'm now doing example 2. It says to find the rectangular equation of the curve whose parametric equations are x equals a cosine t and y is equal to a sine t, where a is greater than 0. So I'm going to start off with our circle, and I'm drawing out the t angle, and so I'll create a reference triangle here. And from the origin to here is going to be labeled as x. And then here's a right angle. And then going up perpendicular is going to be a y value. And then you have your hypotenuse, which I'm going to call as a. All right, so we know that from this diagram, we can write out the cosine ratio. So the cosine of the angle, cosine of t, is equal to adjacent over the hypotenuse. So that is your cosine of t is equal to x over a. And then for the sine ratio, it's sine t is equal to opposite over hypotenuse. So it's y over a. And so then if you multiply both sides by a on this first one, you get x is equal to a cosine of t. And then for this one, you get y is equal to a sine of t. All right, so then after that, I'm just going to use the Pythagorean identity of sine squared plus cosine squared is equal to 1. And so looking at this part right here, I have sine squared t plus cosine squared t is equal to 1. So in place of sine squared, I'm going to put in the y over a and then squared. And then you have plus x over a squared is equal to 1. And multiply the entire equation by a squared, because if I distribute this, you end up with a y squared over a squared. So that'll give me x squared plus y squared is equal to a squared. All right, so what this shows me is that when you have a form of this right here, this will be a circle with the radius of a. Now, you can always also have two different values for a. You could have an a here and a b right here. And there are two other things that you can use. You have a form of what's called an ellipse. So the form for an ellipse is x squared over a squared plus y squared over b squared is equal to 1. And this will be along the x-axis. So a is going to be the distance from the origin to the point A, and then a to a negative a. So that's going to be 0 to negative a. And then for this one here, since it's b squared is under the y squared, it's going to be along the y-axis. So it'll look like this. Another form that you might see is something called a hyperbola. So that looks really similar to the general format of an ellipse. And the difference here is that instead of having a plus, you have a minus. So you have x squared over a squared minus y squared over b squared is equal to 1. And so for this one, if you recall from Algebra 2, you're going to be going along the x, and it's going to be a to the right of the origin and a to the left of it. And so you're going to create a rectangle out of this. Right? So from the origin, it's going to go up b and then negative b, and then you create a rectangle. And then you draw in your diagonals, so that's what the dotted orange line is. And then after that, since the x squared over a squared is a positive, you're going to be drawing your hyperbola over along the x-axis. The other two versions of the Pythagorean identity that you may be using is the tangent squared t plus 1 is equal to secant squared t. And then also 1 plus cotangent squared t is equal to cosecant squared t. If we wanted the curve to consist of different revolutions in the counterclockwise direction, we would change the restriction on t. So if you have something that you want to have for one full revolution, then you can go from 0 out to 2 pi. Half a revolution, you actually have a total of 4 different cases. You could have the upper part, so that would be going from 0 to pi, or the lower portion, and that would be pi to 2 pi, or the left side, so that is pi over 2 to 3 pi over 2, or the right side. Now, for the right side, you can't go from 3 pi over 2 to pi over 2 because this number at the left has to be a smaller number. So instead of calling this one as a 3 pi over 2, you would call it a negative pi over 2, and then it would go out to pi over 2, then that would work. If you wanted to have 2 revolutions, then you would go from 0 to 4 pi. And so on the graph, it would be hard to tell that you went 2 times because it would just be overlapping. You would just have to state that it's gone around 2 times. Okay, for the last example, it says to find the rectangular equation of the curve, then you want to graph the curve by hand and show its orientation, and then graph the curve whose parametric equations are given using a graphing utility. All right, so I'm going to make a truth table similar to what we did on page 1, and I have a column with t and then x and y. So since I'm going from 0 to pi, I'm just going to put in the quadrantal angles. And the reason is that I don't want to use values of pi over 6 or pi over 4 or pi over 3 because those are not going to always come out as nice values, because what is nice for cosine value is not going to be a nice value for sine value. So I'm just going to be using the quadrantal values. So I'm going to put in 0, pi over 2, and pi. So now I will substitute in these values in for x. So at 0, it's going to be 1, so it'll be 2 for x. And then at pi over 2, cosine of pi over 2 is 0, so then that would be 0. And then for pi, cosine of pi is a negative 1, so it'll be a negative 2. And then you do the same thing to find out the y values. So sine of 0 is 0. And then I have sine of pi over 2 is 1, so that's going to be 3. And then sine of pi is going to be 0, so that's going to be 0. Okay, so I know that this is going to have the form of an ellipse. So if I draw this out, I'm going to have your point 2, 0, so that's right here. And then I have 0, 3, and negative 2, 0. So it's starting here, and then I have to put in the direction of the orientation as just going to be top part of the ellipse. Okay, now to make the conversion, I'm going to solve for cosine of t and also for sine of t. So to solve for cosine of t, I divide by 2, so that gives me x over 2. And then to solve for sine of t, it would be y over 3. And then I go back to my Pythagorean identity of sine squared t plus cosine squared t is equal to 1. And then I do my substitution of y over 3 squared plus x over 2 squared is equal to 1. And then I'm just going to switch this around and then square it. So I end up with x squared over 2 squared plus y squared over 3 squared is equal to 1. And so if I compare that to what I have here, along the x-axis, it's going from the origin 2 units to the right and 2 units to the left. And then I also have 3 units going up, and then that would be it. It's not going to be going down because the parameter goes from 0 to pi. Okay, so let's take a look at this on the calculator. So I'm going to just clear this up. And I'm just going to put into my x parameter, I have 2 cosine of t. And then for my y, I have 3 sine of t. And then for my window, I'm just going to make it go from 0 out to pi for my t step, because that's my parameter. And then I'll keep the t step at 0.1. And then for my x min and my x max, I know that I need to have at least a 2 and a negative 2. So I'm just going to go from a negative 3 out to 3. And my x scale, I'll just keep it as 1. And then for my y, I just need to have it going out to 3. So I'll do a negative 4 to 4. I like to just put in 1 above and 1 below. And then the other thing is, on your mode, make sure that you're in the radian mode. All right, so now when I graph this, I get this. Now, it certainly doesn't look like how it's drawn here, and that's because this is wider. And so if you wanted to fix that, you could just go to zoom and make it as a square. And then that'll make it look a little bit more like what is on here.